In this tutorial, I want to solve a little bit more equilibrium calculations related to ice, initial change equilibrium. In a question like this, carbon monoxide is reacting with steam to give you hydrogen and carbon dioxide. The temperature is given, some information is provided, and then final question is what is value of Kc. They tell us initially you have 2 mole per dm cube of carbon monoxide and 3.2 mole per dm cube of steam. And later on, once equilibrium has been established, you have 1.6 and 1.6 of CO2 and H2O at equilibrium. So initially you have no hydrogen, no carbon dioxide. The two reactants start reacting. Some of them gets consumed and products come to life. Then again, we go after stoichiometry. It's 1 to 1, and it gives you 1 moles of each of the product. So you remove x moles, so this is minus x moles of steam is removed, plus x moles of hydrogen comes to life, plus x moles of carbon dioxide. Now during equilibrium you have 2 take away x, and you have 3.2 for steam, take away x. Now x happens to be exactly 1.6 what you find here, so value of x comes to life with this information. Same thing with CO2, x should equal 1.6. So now if that's the case, then we can say carbon monoxide, its concentration at equilibrium is 2 take away x, and we decided x is 1.6, so 2 take away 1.6 equals 0.4 mole per decimeter cube. Same thing with steam, H2O at equilibrium is 3.2 take away x, so it's 3.2 take away 1.6, and it's 1.6 mole per dm cube. Now what is Kc? Kc is simply products over reactant. I write the expression. They are all coefficients of 1, so there is no exponent. Now we simply plug in the numbers we have. At equilibrium we have 1.6 of hydrogen and carbon monoxide, so 1.6 times 1.6 is 1.6 squared, divided by, at equilibrium carbon monoxide is 2 take away 1.6, which was 0.4, multiplied, at equilibrium steam was 3.2 take away x, which was 1.6. When you do this, you will find that your K is 4. So Kc is 4 for this equation at 325 degrees Celsius. Now usually a follow-up question is, same equation is given to you, you know Kc now, and then they start with different initial conditions. So you have 2 mole per decimeter cube and 2. Remember on the last slide it was 3.2. And the question is, what is concentration of each species at equilibrium? So then again, since coefficients are 1 to 1 to 1, minus x mole is removed on the reactant side, plus x moles comes to life, plus x. So at equilibrium you have 2 take away x, 2 take away x, and you have x's for the products. Now Kc, now we know the value, which is 4, is products, hydrogen concentration times carbon dioxide, which is x squared, divided by concentration of carbon monoxide and H2O, which is 2.0 minus x multiplied by 2.0 minus x, which is squared. Now to simplify this, take square root of both sides. So I'm going to take square root of 4 and square root of the products. So this will say square root of 4 is 2, take the positive value of course, is equal to x not x squared anymore, square root of x squared is x, divided by 2 minus x. Now multiply, cross multiply, so 4 minus 2x is equal to x. Take your like terms to other side, so 4 is equal to 3x. So x is nothing but 4 divided by 3, which is 1.33 mole per decimeter cube. Now let's just plug in. So equilibrium concentration of carbon monoxide is 2 take away 1.33, which happens to be 0.67 mole per decimeter cube. Concentration of steam at equilibrium is same thing, 2 take away 1.33, and it's 0.67 mole per decimeter cube. Concentration of hydrogen at equilibrium is x, which is 1.33 mole per decimeter cube, and concentration of CO2 at equilibrium is also x, which is 1.33 mole per decimeter cube.